Welcome back to VTU e-Shikshana program on computer-aided engineering drawing. We are working on module 3, that is development of surfaces. So we have dealt with prisms, pyramids, and now we will work for cylinders and cones. Now let me take cylinder first. Let me have a problem and discuss the same. A cylinder of 50 mm diameter and axis 70 mm long has its base on HP. It is cut by a section plane inclined at 45° to HP and passing through the right extreme point of the solid. Draw the development of lateral face of remaining portion of the solid. Now, before going to actual problem, let me discuss the development and the corresponding items like the top face, base and lateral face. Already we have discussed. So here is the top face and base and lateral surface of the cylinder. Suppose that I will cut this particular cylinder on a particular generator, assuming that there is a cover on this lateral surface, okay, paper cover, and I will open that particular one. Then you will get simply a rectangle. That is the development, that's all. So here is the cylinder, and if you open and place it on the flat surface, you will get rectangle. So this particular height refers to as height of the axis or axis length, and this is pi d, perimeter of the base. Now, or top face or cross section for that matter. Now, if you are having development of complete lateral surface of the cylinder, simply you draw a rectangle and say this is height and this is length of the development, that's all. Now, I will just draw a small sketch so that you will get a clear idea. Assume that this is the top view and front view of the arrangement. Now, if I want development of the cylinder, I will just keep this one, that's all. Parallel method, take starting point one end, and this is the height and this is the top view. Then this is nothing but pi d or 2 pi r. Then this is height of the cylinder. Okay. Now, particularly this problem, we have inclination to HP. It says it is top right extreme point. Here, number of points on the circumference of the top face. If you draw diameter, you will get this is the left extreme point, this is the right extreme point. This is the right extreme point. So, section plane is going to pass through that. In case of prisms, top edge, extreme top edge, extreme top corner or extreme base corner, like that we say. Here it is point reference. Let me draw a line inclined at 45°. Okay, assume that this is the top view and this is front view of that. Suppose that if you keep this on the ground or HP, top view is circle and front view is rectangle, that all of you know. Now, to get the inclination, draw a 45° line, full hyphen, then keep the arrow. Okay, this is top and front view. Based on that, I am working on this. Now, if I don't have section plane, I need not very simply keep rectangle as the development. Show this is the development of the rectangle. Suppose if it is simply a cylinder type, here it is truncated. Definitely you must divide this into n equal parts. That you have done in solids, laminae, etc. So you go to array, circular array, and then divide this into 8 equal parts. Assume that I have taken 45 in manual. Then these are the points of reference. Okay, this is 8. Project these points onto the front view. Assume that these two are coinciding 8 and 2 are coinciding. Yes, this is top face. Now dark the portion which is to be retained after taking section. This is the section plane, and dark the portion which is retained after taking section. Yes. Need not dark the generators, it's always the imaginary, and also it must be very light. Yes. See that the complete remaining portion should be identified. Now, let me name these points 1 dash, 1 1 dash, 3 1 dash, 3 dash, 5 1 dash, 5 dash, in between 2, 4, 6 and 8. 8 and 6 are in bracket. Here also 2 1, 8 1. This is 4 1, 6 1 dash. Now points of intersection with the section plane, because to get the profile there, A1 dash, sorry, A dash, B dash, C dash, D dash, E dash, F dash, G, H. These are the points of intersection with generators, imaginary generators. These are end generators. End generator, the top point itself is the intersection point. Here, A is in between 1 1 1, first generator. This is the middle one. Again, 1 1 1 will be having A only. Now, draw the development of the cylinder. How to draw the development? You know, it's just rectangle. You measure pi d and work out first. Assume that, let me start from a point. So, if I measure pi d from this point, 2 pi r pi d, it will come like this. Okay. Now, this is pi d. Okay. This is 2 pi r. L equal to 2 pi r. So, many values you will get, no problem. Next, there are different methods of dividing this. If you are working on manually, you can divide this into n equal parts by taking an inclined line from this approximately 30 degree to 40 degree, whatever. So, you calculate this total pi r, you will get some value. Approximate to that value you take and then draw number of points. 1, 2, 3, 4, 5, 6, 7, 8. Equal number of points. Then join this to, okay, using rotoscale or mini drafter, whatever. Rotoscale, because you are not using mini drafter nowadays, you can use rotoscale and do it and draw this. Okay. Draw parallels to first line. So you will get all the time the one which is available like this: 1, 2, 3, 4, 5, 6, 7, 8. Please count, must not exceed 8 because you are done this. Now, assume that I am taking equal distances and got the divisions here. So I got little bit changes. Assume that it's all equal. This is how this is the procedure, or you calculate the total divided by 12, approximately you take and do it. But best method is this. Okay, divide that into equal parts. Manually, it may be difficult for you. Try to work out. On computer, it's easy. You can use offset and do it. Now, draw projections for all. Now, before that, let me take 1 dash, 1 1 dash here. Corresponding generators are 2 2 1, 3 4 5 6 7 8. Again, it is 1. 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, again 1, 1. Now draw projections. Simply draw parallel lines. You can restrict to specific generators, but in general you can draw thin lines. It's very interesting and easy also to mark all points. It is like a staircase type. Assume that I am starting from 1. This is the starting point. Say this is direction P. I am looking at this and then keep this as the reference. I am starting from 1. So this is 1, 1 already marked. This is 1. This one is 2. This is 3. Actually, we have made naming A, B, C, D because we have taken this itself as 1, 2, 3. This is A. This is B, C, then D, E. Be careful. Naming is very important. E, F, G, H, again A. Then draw profile, smooth curve covering all the points. You will get curve here. Okay. So since small variation is there, I am getting little bias towards left. Actually, it must be symmetrical. Okay. Now I will show you how exactly you get. Let me complete this. Draw line only for boundary, not for any generator other than end generator A1. Yes. Now this is the pattern you are going to get. This is the development. Now let me fold it. So the same thing I am having. Let me fold it and show you how exactly we got it. So this is the actual cylinder. If you cut with the section plane passing through the top right corner and with an inclination of 55, you will get this as the. So this is the section plane. Okay, cut section. Okay, now if I release it, I will get this time. Okay, so this is the simple method of drawing development of a cylinder with section plane, that is truncated cylinder. Suppose that you are working in a classroom or any test or somewhere. If you peep at some people, doing same thing, they are doing different. You are afraid, I am doing different and reverse is wrong, but not correct. Whatever you are thinking is not correct, but their approach is different. Maybe they have started from 5. Starting instead of P in this direction, Q direction, they might have taken and then started with 5 as a reference. Not the direction, in fact, the position they have taken 5. Suppose that if I take 5 as the reference, what will be the development? Okay, now I will take the same thing and then let me use the same pattern. I will change only this. Use the same figure. Now, this is, I assume that I start from 5 instead of 1, 2, 3, 4. Start from 5. 5, 1, 6, 1, 7, 1, 8, 1. This is 1, 1, 2, 1, 3, 1, 4, 1. Again 5, 1. This is 5, 6, 7, 8. This is 1, 2, 3, 4, 1. Sorry, 5. Okay. Assume that this is Q. Reference is Q now. I cut it 5, 5, 1 generator and then spread it. Then how exactly it looks like. See, this is 5. Starting point is this. So this is the point of reference. Again, then this one. Next this one. Again, this is the point. Okay. And 2, 3, 4, 5. You will get the different pattern. That pattern is given by this. Yes. Now dark this portion. Yes. This is the pattern you get. Okay. Suppose that if you cut at 5, 1, see this is the pattern. Let me close it. Assume that I am going to cover this with the cylinder whatever I have here. Yes. This is the top extreme corner. I cut it here. You will get the. Now I will open it and then show you. This is 5, 6, 7, 8, 1. This is 2, 3, 4, 1. I mean, yeah, 5, like that. Generator reference. Then you will get the pattern. Or there is one more option. Suppose that you have the section plane itself. Different question. The section plane passes through inclined at 45 degree only, passing through the left extreme top corner. Left extreme top corner. Yes. Yes. Then the dark portion to be darkened is this, and this is to be made light as per the requirement. This is made right. Okay. Now you see, this is 1 as previous case. 1 is intersecting at this, 2 at this point, again 3, 4. Same pattern you get for this particular problem. This is the section plane. Okay. So this is how you get different patterns with the same question. Now what I am doing is I am keeping this way. I am keeping this way and changing the section plane. Instead of top extreme corner, I am keeping left top extreme right corner. I am keeping left extreme top corner and cut at this. See, it's the same section plane angle. Then you will get this pattern. Okay. So, or for this problem only, if you take starting point as 5, you will get this pattern. So, all depends on where exactly you start. Normally, by default, we take left extreme point or generator and start working. That is the usual method. Suppose that they change this itself is, you need not worry, you get accordingly. So, this is how you get the development of truncated solids. You may have different questions based on that we will discuss. I have one more in question paper or for test or any classroom work, you may get this particular problem. So that's all they give. This is for part of the cylinder which is cut by 2 section planes of particular angle or distance they give. Say this is 40, this is 90, or they may give 70, this is 35, okay, like that. Then this is the portion and they give something like this, 40, 50 pi and 70 mm height, that's all. 50 pi, that is diameter is 50 and it is cut at a point where 35 mm from the top end from both sides, end generators, and this is the sharp corner in the figure. But how exactly you get the development? So for that, let me take the same thing and do it. Okay. Now 70 mm is the height. Okay. 70 mm is the height. Then measure 35. Okay, 70 total exactly, it is bisecting the axis in that case. 35 means it is bisecting the axis. Otherwise, you can take little less, 30. Okay. Now, join this. Again, instead of 1 section plane, I have 2 section planes. That's all. You have to treat this as section planes. And dark this. Okay. Dark this portion. They will give in words or figure. Okay. So ultimately you get this figure. Now, as usual, you have to draw a circle. Whenever they say 50 pi, you have to draw 50 diameter and then divide this into n equal parts because we have section planes. Then get this. Name these points. So let me even name A, B, C, D, no problem. So A, B, C, D, E, F, G, H. Okay, this is A dash, A1 dash, B1 dash, C1 dash, D1 dash, E1 dash. Just for change I am doing it. Okay, H1 dash. This is A dash, B dash, C dash, dash, H dash. Now we can name 1, 2, 3, 4 for the points of intersection. This is 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7, 8. Now, as usual, you have to do. You know the method, dividing this into n equal parts, that is 8 parts, you divide and do it. Assume that I am going to get this in parallel method as usual. Okay, this is 1. Assume that I have taken pi d and then divided that into n equal part, that is 8 equal parts. Okay, for all practical purposes, you have to use this method, that is dividing the given length into n equal parts by parallel lines drawing here. Assume that I have done that job there. Now start from this. This is A1, B1, C1, D1, E1, F1, G, and H1. This is A1 again. A, B, C, D, E, F, G, H. Again A. Now always see that you might have observed my working here. I never left any gap here because you have to project. But suppose that if you don't project, you never feel like parallel line method you have taken. Height is exactly equal to the height of the cylinder. So you must project. You should not keep any gap between this figure and this. XY line, let it be there. Continue it now. Now start working this particular problem. Easy. Draw only 3 lines. Already top line is available. It all depends on how many divisions you are going to do. So if you do 12, it will be little more, 2 more extra, that's all. Now be careful in identifying the points of intersection. On A1 we have 1 or 2 points. This is 1. 2 and 8, 2 is on BB1, 8 is on HH1, 8. And 3 is topmost point, at the same time 7 is also topmost point. Sorry, this is 2, this one is 3, this is 7, G. Next point is D4 and then 5 for E, then this is 6 for F. Yes, 1, 2, 3, 4, 5, 6, 7, 8, 1. Yes. Now draw the pattern. But very careful in this. See, here is a sharp point having 2 section planes. Definitely you end up with sharp corners. Not here. You will get like this only. This pattern only you get here. But especially in this case, you will get that type. So you will get this particular. Here you will get corner. Again you will get like this. So this is the pattern you get. Okay. So this is the development pattern. What about the remaining portion? Yes. Draw dark line only for the boundary, not for all generators. They are all imaginary generators. Since they are the boundary, definitely you must dark it. So this is how you get. I repeat, this particular portion is curve and these are points only, sharp points, not the curves. So this is specific information for all of you. So this is how you can work any type of problem on the cylinder. Only thing is, the point is from where you start, that is very important. So normally by default you always start from A. Then if they ask specifically like single piece development and all, in that case suppose this particular portion is entirely removed, even including the base, then you start from here only. Suppose that if you start from this point, you will get complete development till this point. Again gap will be there here. Then so try to judge before you start working. Now I will work similar problems on computer. Let me take a problem on cylinder and corresponding development. Assume that there is a cylinder without any section plane. Assume that we have a cylinder which is having its base on HP. For that you do not need any divisions. You can definitely get rectangle of pi d, length of the development, and height equal to height of the cylinder. Here we have sections. A cylinder of 50 mm diameter, height 620 mm is cut by a section plane inclined at 45 degree to HP and passing through the right extreme point of the top face, that is right extreme point of the top face. Yes, here this is the cylinder, here this is the point. Draw the development of the remaining portion of the solid. Normally draw the development means remaining portion of the solid after taking section. Now assume that I have taken the section plane from this point to this point, from passing through this 45 degree. So that is what we have, see here, and corresponding development. How to do this? How to get the corresponding development and divisions, I will tell you. Now for that you have to draw two parallel lines. This is, since it is parallel line method, and the length of the development is pi d, it comes around 157, and you are going for 8 divisions. If you divide that by 8, you will get 19.62. See, this is what you get. Okay, this is the development and corresponding divisions to get the smooth curve, to get the pattern. Now to get this pattern, now I will show you. There are two methods. One is the offset method, other one is rectangular pattern. Now I will tell you both. Now first let me use offset method. For that you have to draw a line. First you have to start with a line, that is, assume that one particular generator, you can start from EA1 or EE1, all depends on the situation. Otherwise also you can start from E1. I will tell you in future how to do it. Now let me have a thin line. First this represents, change the pattern, this represents the particular generator EA1, say. To start with, let me have a thin line. Now select this and offset. So you should have single, that is very important. Okay, after selecting this you will get single accept. Okay, but how much you need? Already I have practiced, that is why it is coming 19.620. Otherwise if there is any other number, you keep the gap. So already we have made this 19.62, you have to keep this 19.62. I will repeat, 19.62 is there. Select this, then you get, you say accept. Then from this, the left side or the right side you want? Yes, 1, 2, 3, 4, 5, 6, 7, 8. See, that's 1, 2, 3, 4, 5, 6, 7, 8. So you need this divisions. So initially we have selected line thickness is 0.7, that is why it is coming. Otherwise you can get very thin line, 0.13 only. Okay, and do it. Let me do this job. Okay, now select further, it is only for practice. Select this, okay, select this offset, then 19.63, select, okay, thin line is there, yes, offset, single, okay, accept, then 1, okay, I have not changed the pattern, thin line, here only you can change, see, like this you can do. How many you can? 1, 2, 3, 4, 5, 6, 7, 8. So, like this you can. If you do not want this, we do not want this dimension. So, what you do is select this throughout and then say cut. Okay. This is how you can do it. You can do this particular type of this one. Otherwise also you can use the rectangular pattern and then do this job. I will tell you how to do it. Okay, now let me erase this. Okay. See that the line command will have the minimum thickness, otherwise you will get always this only. Yes, you keep it ready. Then select this rectangular pattern. Okay. In rectangular pattern, see here if you select this, it will ask how much you want. See, this is we have x, this is the x count, how many. If you want 8, you should keep 9 lines totally it has to, you have to get, and x count is only one row you want. Yes, y count. Then this one x horizontal value 19.62. Yes, then say finish. See, it's easy, better than offset method. You can also choose this, either the offset or rectangular pattern you can choose and draw the development pattern. Now it's easy for us. I have done that job, then dimension it. Okay, then comes the section plane you have done 45 degree, that is what he has given, 45 degree to HP. Then keep this points recorded. Then assume that I have made the required portion dark, then projected all lines, points. See, 1 is on AA1, 2 and 8 on BB1 and HH1, 3 and 7 on CC1 and GG1. Similarly, 4 and 6 on DD1 and FF1. Finally, E is the topmost point 5. So, then you have to draw this and get this pattern using the curve. Now, I will tell you how to use curve. Okay. Now, keep this curve. Yes, curve. Start from this. If you draw projections, you will get continuous line. You prepare this so that with the split command, you try to split from this line to this line partition. Then only you can get end of the line. See, end of the line. Here you get end of the line automatically. You will not do anything. See, end of the line, end of the line. Yes, that's what you do. See, this is light line. Okay. Now, how to make it dark? You select this and then make it dark. Style, you go to style and then 70 or 50 whatever. See, dark this. Then dark the boundary 1 to A1, remaining portion of the generator, again 1A1, then baseline. Okay, that you have to do. So, this is how you get the pattern, and also how to dark all those things. Now, see that this is done here. I have drawn first the curve, then I have made it dark. So, this is how you do a development with starting point A1. Somebody wants to start from E1 for that one particular purpose may be there. So, for that how he starts, see, starting with E1. Now, same overall pattern will be there, development, no change. See, instead of A1, B1, C1, D1, you have to keep E1, F1, G1, etc. and again A1, then B1, C1, like this. It ends with E1, E1. Yes. Then project as usual and get this pattern, then darken. See, same problem, same inclination, starting point is different. You get starting point different, this pattern with A1 as starting point and this point, this pattern with E1 as starting point. This is the difference. Okay, there should not be any confusion. All depends on the requirement, application. Now let us work, instead of this the section plane leaning right, left downwards as per the given this one 45° THP from top extreme, I may take different pattern, left extreme top face, okay, of the top face. So how to get this? See here, top extreme left point of the top face, yes. How to get, again starting point is this, yes, starting point, you do same procedure you have to follow, you will get this, okay. Otherwise if you take starting point as this, you get reverse, that is all. So it is very easy job, only thing is you have to concentrate on the remaining portion and corresponding intersection points with the generator imaginary points, and then get the points on the development you have drawn and dark the required thing. Only boundary you must do, especially when you get cylinder and cone, you never get any edges. So definitely it should be boundary only. Now there is a problem, this is also appeared many times in examinations. They will give directly figure like this or statement, they give the section planes and this front view only, otherwise they give statements. So a cylinder of 50 mm diameter, height 70 mm is cut by a section plane, two section planes inclined 45°, meeting at the diameter of the top face, draw the development of the solid, or they give in it is shown in figure that the section planes are shown in the figure and corresponding front view is given, accordingly how to do this. So how to do it? So you have to start from this 45° and 45° leaning upwards, downwards right and downwards left, then identify the points, divide that into 8 equal parts, same dimension. So same type of pattern is there, overall development, then project all these points. So you will get hardly 3 lines of projection, see 3, 1, 2, 3, top line is coinciding with the top face perimeter. Now this is 1, 2, 3, 4, 5, 6, 7, 8, 9, this is not 9, actually it is 1. Now how to draw this? See here you have to draw the, use the curve command and then start working. Here you get sharp corners, you have to start at this point, again you start fresh, do not continue. If you continue this, you will get this, you never get curve here, this is wrong, okay. This is, I will show you how to do it. Now take this, you will definitely get sharp point, this is intersection one point, and this again this is another intersection, otherwise you can split and go for this one. So stop at this point, next start fresh. Suppose if you continue that, you will get the curve only, so you will get this one here, continuously you do it. Yes, 7, stop here, sometimes it disappears, take care. Start fresh, particularly curved this one, it takes some time, must do it carefully. Yes, now start fresh here, do not continue, otherwise you will get curve, it is wrong. Yes, what you get. Now you dark this, get this one. Now there is another problem, as I told, this is wrong because you never get curve here, it is only sharp corner. There may be another problem, same type, instead of both 45°, one is 30° line, other one is 45° line, okay, because you get difference in height from this top end, distance are different. How you get it? So this is what they give, a cylinder of 50 mm diameter, height 70 is cut by 2 section planes as shown in figure. Draw the development of the lateral face of the solid. Yes, so you divide this into n equal parts, then see that the section points are identified 1, 2, 3, 4, and then project the same here and work out as per the requirement. So, you have to name it actually 1, 2, 3, 4, 5. See, this is the pattern you get. So, here you will get 2 sharp points. Finally, dark the boundary only. So, there may be different patterns as per the angle or dimensions. They give the distance also. Accordingly, you take and name it. See, I named it 1, 2, 3, 4, 5, 6, 7, 8. So, here corresponding identified points are identified. See, 5 is the lowest point, and then 2 and 8 are at the middle, 3 and 7 are touching the top point of the generator, imaginary generator. This is how complete the patterns in cylinder, particularly these are referred to as Rayel patterns. Okay. So, you get the values, the patterns accordingly. Now, see that some more problems are worked out with the different shapes in coming sessions.